Ameeta, we can hear you loud and clear. Thank you very much. Vaidi here.
Great. Thank you so much. All right. So this is what we want to discuss today. And so before I even get started, right, on security and compliance, it's worth discussing and getting all of us on the same page in terms of what is our understanding of a hybrid cloud, right? So when typically we talk about a hybrid cloud, we are basically saying that there is some amount of workload, portability, orchestration, etc., that is happening across two or more environments. When we talk about a hybrid cloud architecture, it is at least two or more environments. And what could these include? It could be at least one private cloud, or at least one public cloud, or it could be two or more private clouds, or it could be two or more public clouds, or it could be a bare metal or a virtual environment that is connected to at least one cloud, which is one public cloud or a private cloud, or a mix of any of these, right? That is typically what is a hybrid cloud. And why is it so important today? It's important because no company is just going with one single cloud strategy. Usually customers are having, and these are the customers we talk to every single day, they're either having multiple public clouds that they're working with, or they have some of their applications on a public cloud and some private. And this is more so with the regulated industries like finance, for example, or government in some cases, right? So there are varying requirements. And the way this whole concept of cloud has evolved, and the whole computing that has evolved, is that it is no more defined by just location and ownership, right? Earlier, for example, if you said public cloud, it just meant that it is off premise, and you are having a bunch of public cloud providers that are running this service for you. But today, it could also mean that they are providing some services to their clients in their on-premise data centers, for example. And then private clouds. Now, traditionally, we used to talk about private clouds as running on-prem, but today you have organizations that are building their private clouds with a rented and a vendor-owned data center located off-prem. So if you really see, the whole parlance has changed, but I just wanted to make sure that we are all on the same page in terms of what a hybrid cloud is. So do I advance to the next slide? Yeah. So we did, and every year Red Hat runs this open source survey that we do with several of our customers and non-customers. And what we've really found is, and this is research that we do, and this is the latest one that we did in 2020, what we found is that a majority of IT leaders, more than 50%, are having a hybrid cloud infrastructure today. And of those that don't, you'll find that over 50% are planning to implement it in the next 2 years. So you can clearly see that this is top of the mind for a lot of customers. And then we also found that open source is also instrumental for cloud, and why it is, I'll talk about it in some time. But when we asked about the importance of open source in that strategy, many of them said that it is very important, a majority, as you can see. And then we asked people in terms of what companies are you looking up to as leaders in digital innovation. And those also, they found that open source was instrumental, and they agreed that open source is used by the most innovative companies. Then we also did something else. We tried to find out, especially in last year's unprecedented situation that we found ourselves in, right? We asked them about what are their goals going forward. And we were really curious about what is going to be the impact of this COVID-19 on their planning, right? And how we can best meet the customer requirements. Here again, we found that digital transformation and security remained high priorities. They always were, they continue to remain high priorities, right? And then a majority of the respondents also said that while they may have stalled some of their initiatives, they are looking at now accelerating it and really stepping up their efforts. And of all the top priorities that they found, the funding priorities had IT security at top of their list of outcomes that they wanted to see. So we didn't ask them to call out one outcome, we asked them to call out 3 outcomes. And in the 3 outcomes, they talked about improving efficiencies, improving security, and then of course, reduced cost. So that was interesting. So today, with all that choice, now that we've established that customers are having some kind of a cloud strategy, and quite often it's a hybrid cloud strategy, which is a mix of environments, then we are looking at, how then can we make sure that with all those choices that you have with the public clouds, the private, the on-prem infrastructure, you have virtual machines, you have containers, you have operating systems, you have runtimes, how are we going to actually maintain a secure environment? How are we going to coordinate security requirements? So the way we think about it is, and I'm sure you do as well, that it has to be, planned from day one. It is not something that can be bolted on, because security is a process. It's not a set of products, right? Although we have a whole plethora of security tools that help us to do a lot of things, but security at the end of it all is starts with a process, which means we need to look at designing, identifying the right security requirements, right? And look at what are the new governance models we now have to put in place, given the kind of heterogeneous environment that we will have to manage the security of. And then you have to make sure, right, through the build, through the run, through the manage, and then how you're going to adapt and continue to drive this. It becomes a continuous and a holistic security process. So and then when you look at cloud scale, there is no choice but to automate. Here in this slide, you will see an example of an Amazon warehouse. And those orange things that you see are Kiva robots. They are completely automating the Amazon workhouse, right? Now imagine if your hybrid cloud is like this Amazon workhouse or a warehouse. And as your IT organization is going to transition from, a virtualized environment to this container kind of an environment, then how are you going to extend your application portfolio? How are you going to add those containers? How are you going to scale the environment? It is almost unmanageable if you have to think about doing it, completely manually. So obviously it's a no-brainer that you have no choice but to automate. So security practices, policies, and tools, according to the analyst firm McKinsey and the recent report that they ran, haven't really caught up with cloud technologies. There's a long way to go. And organizations really have to look at how they're going to reconfigure their security tools when they are migrating to the cloud. Not to say that the existing security tools are not required, but how are you going to enhance with additional methodologies and tooling and automation to make sure that you're really there. And fully deploying security automation can reduce the average cost of a breach by 95%. And turns out that only 16% of organizations have actually done so. And this is as per the recent 2019 cost of a data breach report that I picked up from IBM. So given that, so how are we going to look at security in a hybrid cloud environment? How are we going to connect our infrastructure with the platforms, with the applications? Because organizations definitely want to leverage a cloud to be able to bring in efficiencies, to bring in scalability, to reduce costs, to increase agility, to optimize their data. And there could be several reasons, right? And in fact, from what I hear from a lot of the public, cloud, providers like Microsoft and Google and AWS, etc., is that there has been actually a marked increase in the consumption, since last year. And, more organizations are making that move to the cloud, even if they were dragging their feet earlier. So no matter where one is in the hybrid cloud journey, right, security will be paramount, and cloud security will continue to be a challenge. Hybrid cloud security vulnerabilities, what are these vulnerabilities? Typically it could take the form of, not having the right resource oversight, right? Now you're having a heterogeneous environment, multiple environments that you have to manage, you have to control. You may have unsanctioned public cloud usage, for example, or you may have lack of visibility into the resources. You may have inadequate change control, because today as organizations are trying to innovate, and that is really where this whole concept of containers, etc., comes in, which I will just address in a minute, right? So when you're having that kind of agility, that kind of change, as organizations are trying to be more competitive in the market, as they're trying to bring their applications faster to market, because most you know this when you look across the industry, right? Established players are being challenged by upstarts, who are able to deliver services so much faster, right? Plus, established players are also having to meet, scale up with the demands. For example, last year when we all had to, and we still continue to do in many places, continue to work out of home, contactless banking had become so important. And if banks had to make sure that they were able to provide UPI, services to their customers, then it required them to be able to bring in some changes in their applications, right? So how do you ensure that there is enough change control? How do you ensure that there's proper configuration management? And how do you make sure that there is proper access control, right? And how do you make sure that you do not allow unauthorized users to take advantage of the gaps that may exist in your security to gain access to sensitive data and to internal resources, right? And every day we've been hearing about security breaches that can turn out to be very costly. And each of these, the average cost of each security or data breach can run into millions, not just in terms of lost business, but also in terms of lost customers, lost reputation, right? And the average number of data records, the time to identify, how to contain breaches, all these are just increasing by the day. And even when you're faced with these challenges, through this session today, I hope I will be able to tell you about how you can still deploy a very, very focused security, secure hybrid cloud by adapting some of the methods and how it is different from on-premise when you're talking about a cloud architecture. So that's what I hope to cover. And in order to cover this, the aspects that I want to cover is one, from the application side of things, and the other from the infra side of things, of course, with security operations sitting right in the middle of both of these. So in order for us to understand how applications today are built and run with containers, I just have to take you a little into history. And you'll have to excuse me if you're already comfortable with the idea of containers, because I just wanted to make sure that if all of us are on the same page and understand it in exactly the same way, right? So let's look at what applications look like. And for this, we need to understand the world of containers and Kubernetes. So a long time ago, and when I started, my career, and this is how software development used to happen. We used to develop apps this way. It used to be a single monolithic stack. Everything was tied together and on one particular server, right? So what does that really mean? When I say monolith, okay, monolith means a single massive unit, right? And in software development, if I have to take an example, what it really meant was the entire application was developed and deployed as one single unit. It was a jar file or a WAR file, right? Just to take an example, let's say I have an e-commerce Java J2E application, right? The application is a typical shopping cart application where you can view, you can order products, right? So you will have a storefront, which is the user interface. And then you'll have a few components like a catalog, order, the shopping cart, the shipping information, etc. All that gets put into the business logic. And then you have some data access objects. Now, in a monolithic architecture, all these components will be enclosed in a single application, and all the UI related files, for example, user interface files will be HTML or CSS or JavaScript, right? And the source code files may be some .java files. You may have some configuration files, and you may have some XML files, and you may have some build and dependency files, right? Now, once the application has been tested, you put all these together into a WAR or a jar file, and then you deploy it in a specific platform. and you may use an application server like a Tomcat or whatever. So this is how applications used to be developed. They were monolithic, single code base. And what is a struggle for several years that organizations have been facing is, as the applications grew larger, it took that much more time to test. And if something changed, if you had to bring in some change, then the whole change management process was very painful, where you had to go through the entire code base to figure out what went wrong, and how do you go about fixing it. So one from the application side of things and the other from the infra side of things, it all ran on one server. Now, what happened as a next step with the introduction of virtualization, and you started getting a one-step improvement over legacy bare metal infrastructure, right? So what really happened was virtual machines were able to abstract from the underlying physical hardware, and they were introducing a software layer called a hypervisor. So legacy bare metal servers were only able to support one application. With virtualization, what you had was you had multiple VMs running isolated processes or applications on a single bare metal server, but they were sharing the underlying resources. Earlier, if your hardware was underutilized, there's nothing much really you could do about it. But with virtualization, what started happening was the workload density improved dramatically, right? So you could really jack up the infrastructure utilization rates. And when you are stacking all these VMs onto bare metal servers, you are also making the infrastructure more scalable, because new VMs could be easily provisioned on top of the current infrastructure, and you could actually respond to increased demand very easily. And as the adoption of software started growing, this became extremely invaluable, right? And you found a lot of companies started really embracing this whole virtualization and virtual machine concept. So workload portability also improved, because you could really respond to whatever is the scaling that is required. But it also was a problem still, because the VMs were still locking in the service providers into their particular virtual machine formats, right? And then migrating a VM meant that you had to also migrate the entire OS along with it. And then, along with that, we saw the rise of this whole concept called DevOps, right? All of you are probably familiar with DevOps. Earlier, when software development used to happen, we used to toss it over the wall. We used to call it tossing it over the wall. People would work in silos. The developers do something, toss it over the wall to the testers will test something, and then everyone was working in silos, and then you toss it over to the operations. And as we started looking at how we can make our processes more agile, how we can make our processes better. Earlier, we had this whole waterfall model. Used to find IT teams spending a lot of time gathering requirements, and then spending time on design, then spending time on the development. And then, when it came to testing would happen at the fag end of a development life cycle. And at that time, when you find something has changed or something has to be fixed, it was a big task to go back and fix all the problems, right? So that's how DevOps came about, to make things a lot more simpler, development and operations on the same page. And when I say DevOps, it's not just developer and operations, it's all the roles that comprise an IT team, right? From business analysts to the developers, to the testers, to the security, to the operations, right? And this really helped us. And virtual machines was a new era of how we were doing things. And then, we had what we call the container revolution. Now, this is a new concept, that was introduced in order to bring in even more efficiencies. Now, I was telling you that end of the day, it was still monolith applications, right? We were trying hard to bring modularity into these applications, so that if we have to make a change, we could make those changes quickly. And the only way you can do that is if you can break an application into smaller, units. And that is when the whole idea of breaking up a monolith to microservices came about. And, if I look back, some years ago, this concept, from a design pattern was always there. How do I break up an application into smaller modular units, where each of these microservices deals with one piece of functionality, and that can be changed, as required. Now, but practically, to make it a practical possibility was still a problem, because in theory it sounded very nice, but how do you really do it, right? How can we bring further resource efficiencies, and how can we? So almost all the successful microservices stories have all started with a monolith that got too big and had to be broken up. And this was a statement made by Martin Fowler, who's a very well-known figure in the IT industry, especially around design patterns. So given the problems that monolith applications had, given the problems that VMs are having, containers really looked at addressing both the challenges, because container technologies introduced what is called the operating system abstraction, right? So multiple containers are able to leverage the same underlying OS. Okay, and each container, think about it as a functional unit. Okay, and when it is used on top of a virtualized environment, containers were able to improve the VM workload density, because multiple containers could be packed into the same VM, right? Unlike earlier. And then containers can also be deployed directly onto bare metal servers without the use of a hypervisor at all, right? So deploying containers directly onto bare metal servers means that you're freeing up the resources that would have otherwise been allocated to the VMs, right, to the VM OS instances in a virtual environment. And this essentially means that containerized environments on bare metal support the same workloads with less resources as compared to a purely virtualized environment. And additionally, you are now freeing up the workloads from the underlying infra dependencies, and you're making them extremely portable, right? So let's look at it from a DevOps team standpoint. What this means is that is now there is more flexibility in terms of where the applications can run. I remember, a long time ago when, I was developing software, we had to wait for, the testing environments and, to be able to even check, how our applications will run. And, it all depended upon what was that underlying, environment quite often. Even a time when, for example, I worked with the defense research labs on some embedded systems. Each one of them, had to look at what is the environment and what is the real-time operating system running in that environment, and we had to compile the code for that particular real-time operating system each time, and it would depend on it would differ from one to the other. So now, with this concept now, containerized workloads are no longer locked into a proprietary VM format, and it can be moved seamlessly across multiple local or cloud hosts. So containers are technologies then that are allowing you to package and isolate your application with its entire runtime environment, which means all the files that are necessary for this application to run is contained in that container. So now what it becomes very easy for us to move the containerized application between the environments, whether it's development environment, test environment, production environment, etc. And you're still retaining the full functionality. So this then container then becomes a very important part of IT security, because if you build security into the container pipeline, and if you're already defending your infrastructure, then you can make sure that your containers are reliable, scalable, and trusted. Okay. So if I ask what are containers and what does it do for you to a developer, right? The answers we get are very different from what you will hear from somebody who's managing the infra to somebody who's developing an application, right? But all said and done, they are a hot topic today. They have broad appeal because of the ability to easily package an application and all its dependencies into a single image, right? And that can be promoted to development, to test, to production without change. And also, you can now have consistency across your environments, and including different deployment targets, whether it's physical servers, VMs, private cloud, public cloud, or a mix of public clouds. And all of this helps the teams to more easily develop and manage the applications. And that is helping to drive business value, because customers are really looking at how they can be agile, right? How they can make their businesses more responsive. And if they have to make their businesses more responsive, it is easier if they look at their entire application landscape and look at which applications need to be agile. Which are the ones that, users, clients are interacting with. Those are the applications that have to be very responsive. Those are the ones that need to have the right user interfaces. Those are the ones on which they can roll out new offers, right? And if they're able to deploy them as containers, then changing those containers, becomes so much more easier than it was for them to do it earlier, right? And at the same time, if they have to do all this, the enterprises need to have strong security, right? So for developers, as I mentioned, it makes it easy for them to build and promote, because all the dependencies that this application has is contained in the container itself. And then for the infra folks, for the operation folks, the containers represent a sandboxed application process on a shared Linux OS kernel. Containers are Linux, by the way. So Linux is very integral to this whole concept of containers. And that's the reason why you'll find a lot of the public cloud vendors are also betting on Linux in a very big way. So what happens is, for the infra, it means that you're having simpler, lighter, and denser than your virtual machines. The containers end up being simpler and lighter, and they're portable across different environments without you needing to worry about, where it is actually going to run. So with that, let us look at, how we can create, deploy, and manage containers at scale with security in mind, right? Because now, when you have a distributed environment, you're now getting massive scale, because you can have multiple instances of an application. Where earlier you had to do vertical scaling, now you can do horizontal scaling, right? Vertical scaling earlier meant that you were just adding more, VMs, or you were adding more instances of VMs, or you were just adding more physical servers. Now in the cloud, you can just imagine the kind of scale that you can have for a number of workloads and use cases that are big or small. The containers will give your team the underlying technology needed so that they can go about what we call cloud native development for the cloud, right? So you can get started, you can do your DevOps, you can build your CI/CD pipelines, continuous integration, continuous delivery. That has become the way to go about doing things today for organizations, because you can't just deploy an application and forget about it, right? There is feedback, there is change that comes back. You have to do some integration. So this continuous integration, continuous deployment is something that has become mainstay. And container-based applications can now work across highly distributed cloud architectures. And then you can have all these supporting application runtimes, the middleware, etc., to provide that unified environment for your development, for your delivery, integration, etc., right? And all these integration environments, you can deploy them also in containers, these integration technologies. And you can also connect apps and data very nicely, because you have capabilities like real-time data streaming through the open source project, Apache Kafka. And if you're building a microservices architecture, then containers become the ideal deployment unit, and each microservice, can really be very well, containerized. And then if you have to look at how then these containers will, find each other, then, you can look at a complete, what we call a service mesh network, right? So a lot of concepts, but I just thought I will introduce these concepts for you to be able to understand, everything else that I say. So that's the reason why I spent some time on this. So for businesses, it means that they have ultimate portability across multiple environments, and moving to containers for many companies that we talk to has been one of the best decisions ever. Then I get to the next point. When you talk about containers, you also talk about Kubernetes. Kubernetes is an open source project that helps, and this has become the market leading container orchestration platform now. So what Kubernetes does is it orchestrates the containers, because what happens is, if you are going to break up your large applications into smaller units, and then each one you're making a discrete functional unit, each one in a container, after some time you'll have a proliferation of containers. There'll be a sprawl of containers. How do you manage that? And especially in a distributed environment, right? Now you're saying you don't have to worry about the underlying environment. It could move between public cloud, private cloud, in your data center. Then how are you going to manage it all? So that is where Kubernetes, comes in. It also, in some places, you'll see it referred to as K8s or, Kube. So it's an open source container orchestration platform. So what it does is it helps you to automate many of the manual processes that may be involved in deploying, managing, and scaling your containerized applications. In other words, you can cluster together, group of hosts which are running these Linux containers, and Kubernetes will help you to easily and efficiently manage those clusters for you. And Kubernetes clusters can, as you can see in this, span hosts across on-prem, public, private, or hybrid clouds. And for this reason, it has become an ideal platform for hosting cloud native applications that require rapid scaling, right? And some of you may already know this. Kubernetes was originally developed and designed by engineers at Google. In fact, Google was one of the early contributors to Linux container technology as well. And they've also talked about how everything at Google actually runs in containers. You'll be actually surprised to know that Google generates more than 2 billion container deployments in a week, and they have an internal platform, called Borg. And that was the predecessor to what we know today as Kubernetes. And the lessons that Google learned from developing Borg over the years, it became the primary influence behind much of the Kubernetes technology today. And sometime in 2015, Google donated the Kubernetes project to, at that time, a newly formed open source, cloud native computing foundation, CNCF. And Red Hat was one of the first companies to work with Google on Kubernetes, even prior to the launch. And today, Red Hat is the second leading contributor to the Kubernetes upstream project. All the projects that happen in the open source community, we call them upstream projects. And when Red Hat brings them downstream as products to our customers, then they become products. But whatever is in open source, they're typically upstream projects. So now with Kubernetes, you can orchestrate, the containers across multiple hosts. You can make better use of hardware. You can maximize the resources. You can control and automate the application deployment and updates. You can, if your applications need to be stateful, then you can, also mount and add storage. You can scale your applications on the fly. You can declare, how you want to manage the services so that the deployed applications are always running exactly the way you want it to run. And then you can also run health checks. You can self-heal your apps. You can do auto scaling. You can do auto, restart and things like that. So a lot of things. And one thing you have to keep in mind, and this is something that we keep educating our customers as well. A lot of times people think about containers and they think about Kubernetes, right? Kubernetes is an orchestration platform that does what I told you it does. But in addition, there are some other open source projects that feed into Kubernetes, that helps Kubernetes realize its full value. For example, where are your containers going to be there, your container images? You need to have a registry, right? And there are projects for that in the open source community. Then what about networking, right? That is important, especially when you have to do intelligent edge routing and things like that. Then you need to have some telemetry. So that there are some open source projects for that. Then about security, there are many open source projects that are focused on security, like Security Enhanced Linux, for example, SE Linux, or RBAC, role-based access control, or OAuth, or LDAP, and this is especially required when we're talking about multiple layers and multi-tenancy layers, right? Because now you have multiple developers working on their set of applications in containers. How are we going to do all that? So all those services, there's a very rich catalog, of these projects, that you can actually look at. So a comprehensive approach is required when you want to secure containers and Kubernetes. And for the rest of our discussion, the way I'm going to structure it is from building and then deploying and then running, right? Because securing containers is just like securing any running Linux process. You need to think about it through the layers of the solution stack. And you also need to think about it throughout the application and the container lifecycle. It has to be, like I said, a continuous process, and it has to be integrated into your IT lifecycle. And containers are making it easier for developers to build and promote, as we have discussed. And it also makes it easy for you to get the most use of your servers by allowing multi-tenant applications on a shared host. Okay. And as you know, applications are very rarely delivered in one single container. So even a very simple application that has a front end, a back end, and a database, and if you want to deploy modern microservices based applications, then there are a lot of complexities involved, and you need to be able to consider a lot of things, like, for example, which host is it going to be deployed on, which host has more capacity, which containers need to have access to each other, how will they discover each other, right? How do you control access to and the management of the shared resources? How will you monitor the health, right? And how will you automatically scale? So let's start with the build. So the first number one thing, when you want to manage security is you have to be interested in terms of what is inside your container. The content of the container becomes extremely important, right? For some time now, containers now have been around. I told you 2015 is when Google had, and by the time this has become mainstream, I think it's been 4 or 5 years now. So for some time now, applications and infrastructure, we have been able to compose them from readily available components. And many of these are available as open source packages. For example, Linux operating system, Apache web server, JBoss enterprise application server, node.js. You have containerized versions of these packages. They are available. So a lot of times you don't have to start building your own, but just like any code that you download from any external source, you have to know where did this package originate from, who built the package, and does it contain any malicious code. So you need to ask questions, right? Will the container contents compromise my infrastructure? Are there any known vulnerabilities in that application layer? Are the runtime and OS layers in the container up to date? Very important, right? And then how frequently will this container be updated? And how will I know when it is updated? I'm not talking about the application part of the content of the container, which the developers will develop. I'm talking about the images that are available today in public registries that you can use to build your containers. And these are the ones that are your OS images, your runtime images, your application, development, frameworks, and those kind of things, right? So Red Hat has been, for example, you will have to pardon me if sometimes, I will refer to what we're doing at Red Hat. It might help you relate to what I'm saying, and that's the only reason I'm talking about it. So for example, Red Hat has been packaging and delivering trusted Linux content for years in Red Hat Enterprise Linux, right? And across our portfolio. So now Red Hat is delivering the same trusted content packaged as Linux containers. So we have something called Red Hat Universal Image, and you can take advantage of that so that you get greater reliability, security, and performance of the Red Hat container images. And there is a standard called Open Container Initiative, OCI, and these containers have to be OCI compliant, right? So this means that you can build a containerized application on top of that Red Hat Universal Image, and then you can push it to the container registry of your choice and share it. Now, we also provide a large number of certified images and operators for example, various language runtimes, middleware for databases, and several more, through a catalog. So what happens is these are all Red Hat certified, containers and operators. And wherever Red Hat Enterprise Linux runs, from bare metals to VMs to cloud, these will be guaranteed to work, and they're supported by not just Red Hat, but also our partners, our ecosystem partners, right? So as a company that is publishing these images, we are making sure that we are continuously monitoring the health of these images, right? And there is something called a container health index, which will tell you what is the grade of each container image, which means to say how this particular container image should be curated, consumed, evaluated, right? So for example, what is going to be the impact of an unapplied security errata, right? And security erratas are published on a regular basis so that you can really know whether this latest image has applied, has provided, the necessary fix, for that particular, gap that was there. So whenever we release security updates, whatever fixes we come up with, whatever vulnerabilities that we have been able to identify, we rebuild our container images and push them into the public registry, right? And then we have security advisories that will alert, our customers that there are some newly discovered issues in some certified container images, and then we will direct them to the updated image so that they can in turn update their applications that are using that image. So this is to give you an example about what I mean when I say trusted container content. Now, I was just talking about, for example, how Red Hat does it. But let us say, you're not using Red Hat. Then what would you do? There are container scanning tools, that will continuously update. They will look at what are the vulnerability databases, check those to make sure that you always have the latest information on what are some of the known vulnerabilities when you're using some of the container images from different sources, right? And because this list of known vulnerabilities is constantly evolving, right? It's never static, which means you need to check the contents of your container images when you first download them, and then you have to continue to track the vulnerability status over time for all your approved and deployed images, just as we do for the images that we have published, right? And there are, for example, pluggable APIs into Red Hat Enterprise Linux, which will support multiple scanners that may be there, right? You may have something like a JFrog X-ray or a Black Duck Hub or a Twistlock or OpenSCAP, right? So these can be plugged into Red Hat Enterprise Linux so that you can then scan and look at some of the other vulnerabilities that may exist. So that is one part of it in terms of container content itself. Make sure that they are from trusted sources, especially the ones that you are just using from some public registry. The second thing is, how are you going to, look at, where these images are coming from, right? And having a secure access to it. Because don't forget, it's your teams that are going to be accessing these registries, accessing these container images. Then how can you, there are many public sources of container images, right? And when you're going to look at a public container registry, then you have to add a layer of protection by using, some, rules that say that it has to come from trusted sources, so you have to look at what is the certification being provided by that particular image owner. And then you may want to look at, whether the security updates have been adhered to. And then, what are some of the other security considerations? The more you do, you'll really have to look at how you're going to manage access, for example, and how you're going to promote all those container images for your teams to use, which ones they'll be allowed to download, and the ones which you're going to build, and how are you going to manage access to, how are you going to manage the configuration management, right? Because these will go through multiple versions. Then it becomes, extremely important in terms of access controls, how strong they are, and how you're going to support integration with different registries, public as well as private. So this is again an important aspect when you're building your containers. Then the third part of it is, as with any application, right? You have to manage your builds, and you have to look at, that is a key part of securing your software stack, right? So that whole build environment is equally important, and you don't want developers doing the build on their laptops and then deploying that build to production, right? So you have to make it easy, and that's where DevOps comes to picture. That's where a CI/CD process comes into the picture, where you are making it easy for development and ops teams to be able to collaborate on a reproducible build environment, right? So for example, if you're using Jenkins for continuous integration, and how are you going to integrate it, with your own CI environment? Once a build is complete, are you going to push it to some registry? That registry could be, for example, Red Hat OpenShift's Atomic Registry, or it could be JFrog's Artifactory, and you have to look at then how you're going to manage access, as I described earlier. And then when you're working in a very highly regulated industry, right, you have to make sure that the way you design the whole container image management and build process has to be extremely important. So an operations team, for example, should manage the base image. The architects team perhaps should manage the middleware part of it, right? And then the developers should only focus on the application layers and just write the code that goes into that particular application. So this is something that you have to do, and you have to proactively then check for container contents over time. And the best way to do that, as I mentioned, was to make sure that you've integrated automated security testing into your build and your CI process, right? Run your component analysis tools, the tools that provide you the real-time updates on some of the known vulnerabilities, and then include some policies that will flag whichever builds are having issues that have been discovered by the security scans, so that your team can take proper action before it moves to the next step, right? And the next step is, as I already said, you have to integrate security into your entire application pipeline, right? And you have to apply the right security policies, validate the signatures of various container images, monitor, and then rebuild and redeploy as needed. This is an ongoing practice, and this is something that we continue to advocate to all our customers. So I hope it's fine till now. I'm just going at a stretch. So is there something I want to pause? Yes, Vedi.
Ameeta, there are a few questions.
Okay.
Can we take a few questions and then move ahead?
Sure. Let's do that. Yeah, this is a logical place to stop because I talked about building containers. It's a good time to stop. Please.
Okay. So I will read out the questions to you, Ameeta. You can answer because the first question is from Mohan Naik.
Okay.
Can we use containers to run applications which are not cloud ready?
Yes, you can. In fact, the interesting thing that we are doing now is with a lot of customers, right? When we are talking about moving to the cloud, or when we're talking about digital transformation, it's a journey, as you can imagine, for most customers, right? Many of them are not ready. You can't just do one big bang, thing of looking across the applications in a customer place and say that I'm going to containerize all of this, right? It's not even required in some cases. So what we typically do is, we play that role of that advisory, where we go and we try to understand from the customer, first of all, what is their application landscape? Which are the applications? There are some applications that are just running. It's their systems of record, and there is no change happening to it, and it's just stable and there's nothing required to be changed. And then there are those pieces of their business that are constantly evolving, constantly changing, and some applications that need to constantly be changed. So what we try to do is we segregate them, and then we look at which are those low-hanging fruits, which will show immediate benefit to the organization if they go about with their containerization strategy. And those applications, we tell them that they have to look at either refactoring, to make them more cloud native, or rewrite to make them more cloud native, is what we try to do. And, when I say refactor, many times there are Java frameworks. For example, a lot of applications in the world have been written in Java. And then, you have frameworks like Quarkus, in the open source that help, to make, Java was written at a time when it was monolithic applications. And today we're talking about a cloud native world, right? But Java applications are still running, and they're running businesses today. You don't have to change, a lot of things in Java still work, but some of the redundancies can be removed by applying this framework and helping customers move their Java applications to a more cloud native way of doing things. Now, there are some things that the customers want to use the efficiencies of the cloud, but not necessarily want to containerize. So we talk to them about lifting and shifting, right? So we just talk about re-platforming or re-hosting from an on-prem to a cloud. And then, there are some that we may just leave it as is, because like I said, some customers, is financial services industry, for example, they cannot put some things on the cloud. And, it's important for them to continue to keep them on-prem. Those, we continue to keep them there. And because, we are trying to make it easier for customers going forward, we are now allowing the VMs to also be containerized, so that, to your point, that you asked in terms of, is it necessary that we contain, what if we can't containerize some, or we don't need to containerize them, but we want to continue to run them as VMs, for example. We can containerize those and still use the same Kubernetes orchestration platform to manage both those VM environments as well as these containers, so that you have one single place and a pane to kind of have a view across your landscape. That is the latest capability that we have added now to that whole Kubernetes orchestration platform in OpenShift. I hope I answered your questions. Little long drawn, but to
I
your
know.
answer, there is no magic wand. It will not happen. It will have to be a journey, and people will do it in small pieces, as they progress.
So I'll take one more. I'll combine a couple of questions because different people have asked a question before you go to the next one.
Yeah.
Ameeta, I'm just
Yeah.
trying to press these questions. So there are two questions on the container for on-premise application. How to ensure container security on on-premises and how to validate the registry.
Yeah.
And fundamentally, there is also a question about how do you manage these vulnerabilities. So these are kind of related questions, so I thought about it. Fundamentally, it is about how do you manage container security for on-premise application, which I think is an extension from what you answered earlier. So I'll just
Correct.
leave, and after this we can continue with the presentation. Yeah, thank
Correct. It's exactly the same as you would do for, that's exactly, what, I'm talking about. So, same principles that you would apply in terms of who has access, who can, access this, who will manage these images, in the on-prem environment. All those role-based access controls will have to be very clearly defined. And, you will definitely, if it is on-prem, you will have a lot of your traditional perimeter, controls and other things that will anyway be there. So principally, I would say that, the same security policies that apply, while we say that everything that applies in on-prem continues to apply in the cloud plus some more, I would say that, whatever you are already doing in on-prem, that will continue to be there. And like I mentioned, there are several tools, and each image that gets published in a public registry from where you would use, or in a private registry, will have to provide the certification. And there are certain standards that they have to adhere to, and they have to publish what are the vulnerabilities detected. So whichever vendors you are using, and whichever published images of theirs that you're using in a private registry, or from some place that you're downloading to use in your on-prem environment, you will have to make sure that those things are done. And like I said, there are some tools that are available in open source, as well as there are others that will help you do that scanning, to tell you whether there are certain published vulnerabilities that this particular image has not applied, and things like that.
Okay, thank you, Ameeta. There are questions pouring in, but I don't want to hold your presentation.
Yeah.
To all the participants who are asking questions, we will get to you. I know some of the questions we have not yet gotten to, so but please keep putting your questions and we will get back to you. Go ahead, Ameeta. It's over to you. Yeah, thank you.
Okay, so let me get to, so this, whatever I talked about so far was in terms of looking at what is the content of the containers, looking at where these containers come from, that's the registry. And then third was looking at how you're going to make sure that security is built into your entire CI process, the continuous integration part of the process of your CI/CD, and how you're going to integrate security into your application pipeline. This becomes extremely important in the build part of your applications. Now I want to touch upon the deployment part, right? Now you have built your application. Now, in case something falls through during the build process, where you found a vulnerability, you discovered after an image has been, you have to have, let's say you found this out after you deployed it, right? Now you have to have another layer of security tooling, right? Tooling for some kind of automated policy-based deployment. It's particularly important as a best practice, so that you're not patching some running containers, but instead you use some triggers to be able to rebuild and replace. Okay, the good thing about containers is they can be spawned and they can be destroyed. So only thing is you have to make sure that the right version of the right image of that container is the one that is in the production environment, the one that is the most updated one, right? So for example, okay, let's look at an application that is built using 3 container image layers, right? One is the core, which I talked about, which was the operating system. Then you have the middleware, and then you have the application layer. So there are 3 container image layers. Now, if any issue is discovered in the core image, then that image is rebuilt. Now, once the build is complete, that image, for example, let us say it is RHEL, the operating system. Okay. Then what Red Hat would do is we would push it into that build is now complete. We have updated it and we push it into our registry, which is shared, right? Then what happens is a Kubernetes orchestration platform like OpenShift, it will detect that this image has changed. So what it will do is for builds that are dependent on this image, there will be triggers that have been defined. I was telling you about triggers, right? So triggers would have been defined. So what OpenShift will do, it will automatically rebuild that application image, incorporating all the fixed libraries. Because remember, a container contains all the runtimes, the libraries, everything required for that container to run, right? So triggers can also be used to automate the deployment of the updated image. Now the image is updated, right? And now we have to deploy it. Now, when you have, that's really the value of a Kubernetes orchestration platform, to make sure that it automates some of these things. But you have to be very, very careful that you put the right triggers, put the right rules. Otherwise it can end up being a mess if you do not, monitor this. So patching vulnerabilities is one part, okay, of securing your container deployment. Another is managing what containers are okay to deploy in which environment, right? So there is a concept called security context constraints. It's called SCC, okay, that you use to define a set of conditions that a pod must run with. Okay, a pod is one that contains a set of containers on a particular host. Okay, so you can define what are the set of conditions that a pod must run with in order to be accepted into a system, right? So in order to do that, by default, okay, when you're adding it to the cluster, there are two what can I say, SCC, security context constraints, that are applied by default, which is privileged and restricted. Okay, which means if you're when you're talking about running of privileged containers, okay, this is a key security concept, that the process should be run with the least possible privilege. Okay, so this is true for containers as well. So what we're saying is, you don't want the containers to run as root unless absolutely necessary. So what are the capabilities the container can request to be added? Which are the host directories? And then what is the security enhanced Linux, right? SC Linux, what we're talking about, of that particular container. What is the user ID? All this information, gets baked in. So ultimately, by leveraging CI/CD and a Kubernetes a platform to help orchestrate the entire process of rebuilding the application, to incorporate the latest fixes, testing it, and then ensuring that it's deployed everywhere within the environment, you can 100% automate it. So managing the container deployment to replace affected images, using policies to gate what can be deployed, and what cannot be, all these things go into managing your container deployment. Another part of the deployment also is the entire container platform itself, right? So for an enterprise, just imagine, you are deploying containers at scale. We're not talking about one or two, right? We're talking about, I gave you the example of Google, right? In a week, how many containers? So you have to look at container deployment at scale, right? And that is really the reason why there are a whole bunch of tooling that you will use to deploy multiple containers on the same host or on distributed across multiple hosts or nodes, right? So any orchestration platform, a container platform, will deliver one orchestration, that is, orchestrating between all the various containers, which container is communicating with which container, which one needs to access which container, and then the automation of the scheduling and the running of those application containers, whether it is on physical or on virtual machines, right? And Kubernetes, I told you, was originally developed by Google, and it uses a concept called masters to manage the complexity of this entire cluster orchestration, right? So what happens is, this orchestration master becomes the central point of access, and that central point of access should receive the highest level of security scrutiny, right? So that particular master, Kubernetes master, will have a built-in role-based access control, and you can integrate it with whichever is the identity provider of your choice. So one of the key values of a container platform is that developers today can have a feature which is called self-service, right? You don't have to wait anymore for somebody to provide the environment where your application has to run. This whole concept of self-service, thanks to even the plethora of public cloud services that are available today, there is that amount of developer self-service that is there, which makes it easier and faster for development teams to deliver applications built on whichever are the approved layers, right? So you have to look at multi-tenancy security in your platform itself to make sure that the teams are not accessing each other and each other's environments without authorization, right? Otherwise, you'll end up going and changing something that somebody else had done. So you need a self-service portal that gives enough control to the teams so that there is a spirit of collaboration. Otherwise, it defeats the whole purpose of DevOps, right? But at the same time, you have to be able to have the necessary security checks in place in terms of who accesses what, right? So for example, all access to the master is through the TLS, right? Transport layer security. Then any access to the API servers, because a lot of the communication happens via APIs, it has to be token based, right? And there are certain certificates like X509, that's a digital certificate that uses widely accepted a PKI standard, right, to verify that the public key belongs to the user or that computer or that service, whatever is the identity that is contained within the certificate. And then you also have certain concepts like project quota, which you can limit how much of access a person can have. And then there is also a concept of etcd, where it's a consistent and highly available value key value store, and it is used as a Kubernetes backing store for all cluster data. So there are several concepts. I know that our time is very short for me to get into every detail, but Kubernetes has a concept of secrets management. So Kubernetes secrets will let you to store and manage sensitive information like passwords, OAuth tokens, your SSH keys, and storing confidential information in a secret is safer and more flexible than putting it directly in a pod definition or in a container image, right? And then you can mount the secrets into the containers using a volume plugin, and then the system can use the secrets to perform the actions on behalf of the pod. Like in a pod, if you have multiple containers owned by different developers, the secret management will take care of who can access what, and then it'll help you in that part of it in terms of how you manage this. And then there are a whole bunch of compliance checks that you might need to run based on whatever compliance requirements your particular company needs to adhere to. And there are in Kubernetes a concept called operators that will help you to assess the compliance of all your platform layers, right? There is an integrity operator, and you can run integrity checks on your cluster nodes on a regular basis. And when you're deploying, you also have to look at what is the attached storage. So securing your attached storage is also important, because container platforms definitely provide that orchestration, but we also provide, as a part of the container platform, we also provide plugins so that you have multiple flavors of storage, whatever it might be, right? It could be AWS Elastic Block, or it could be NFS, or a Gluster, right? So a persistent volume can be mounted on any host in a way which is supported by that particular resource provider. Then you can have block storage, and you could have, for block storage, typically OpenShift, at least from Red Hat, uses SC Linux capabilities, so that you can secure the root of the mounted volume and make it only visible to the container that it is associated with. And then you also have access to shared storage, like Ceph, Gluster, etc. And that you can do by managing, by adding some kind of a group ID of that particular persistent volume to that particular group in the pod. And then that will, will determine who will have access to the contents of the shared storage. So these are some of the ways by which you could, look at a container that is deployed. And of course, you have to have certain policies, deployment policies for the container deployment, as well as how you're going to manage multiple clusters, right? Strong security, if you want to have, you have to have automated policies, and that will help to make sure that you are quite safe from the way you are deploying your containers and making the best of this really beautiful, concept that has, seen the light of day. I remember, Vaidi mentioned that about Rational, right? When I started my career with Rational Software, those were the days when we had to talk about object-oriented analysis and design before, somebody could start using Rational rows as a tool for designing their architecture. And I remember, while explaining the concept, we used to say, if this is your system, break it up into subsystems. Every subsystem has to expose its interface and hide its functionality. Theoretically, it sounded great. Break up your system into subsystems, encapsulate the functionality, expose the interface. But believe me, people's eyes would glaze over, and they would, not really understand, what on earth is she talking about, and how on earth are we going to actually implement it, right? But I'm so happy I have lived to see the day when we can actually do it. It has become practically possible, and we can automate, containers, and really be able to take advantage of the agility that it is bringing to our applications, allowing just that container to be changed, rather than the entire application, right? Imagine what a blessing it is for organizations, compared to the way it used to be. And with standard container images available in registries for your OS, for your runtime, for your, you're making it so much more easier to create these applications, and which means that developers today can just focus on the business logic of the applications they are managing, for their particular companies. So the deployment policies that you put in for your cluster management, it can be policy based, and and how I won't get into the details of how you can do that, but you'll have to look at how your deployed instances, what will be the configuration, what will be the authentication, what will be the authorization, and how you're going to pass data securely to your applications wherever they run, things like that. And a lot of these things your container management platform will help you run, so you don't have to worry about it looking so complex now. That's exactly why container platforms like Kubernetes help you there. And then the other important part of it is when you're getting into this whole large scale rollout, right? Then you really have to look at how for a very large high availability global deployment, and we're talking about these large organizations that have several of these containers, right? And they need multiple clusters, they need multiple availability zones, right? So you have to look at federated clusters so that you have some kind of common management of deployments or migrations across multiple cloud providers, right? Because you may have something on AWS, you may have something on Google Cloud, you may have something on Azure. And if you're managing federated clusters, you have to make sure that your orchestration tools are providing the security need across the different deployment platforms. And again, authentication and authorization is really the key. So there are concepts like federated secrets, which will automatically create and manage the secrets across all the clusters in a federation. And it will automatically ensure that these are kept globally consistent and up to date, right? Here we're talking about different regions, as I mentioned, across the world. And then you also have things like federated namespaces, so that you can create namespaces in that particular control plane to make sure that they are synchronized across all the clusters in that particular federation. So any kind of strong security in this particular area will need automated policies, because then you can take most advantage of managing your containers and cluster deployment and have a single view, management view across, no matter where your clusters are deployed across the world, across multiple clouds, etc. So these are some of the key things to look at when we are looking at deploy. I will pause here again. If there are any more questions I can address before I move to the next and last section.
Thank you, Ameeta. Actually, there are quite a lot of questions.
Okay, I'll take one and then move on. Otherwise, I'll never cover this.
I know. Quite a lot of questions, but we will try to, I'll just try to pick up.
Yeah.
Try to pick up something. Okay. Okay, two questions. I mean, these are two different questions, but still.
Okay.
First thing is, simple question: how frequently the known vulnerabilities are updated on containers, or how do we update it? That's one question. Let me just pull out the other one.
Yeah.
Are there any scripts, tools, apps, available that can be used for container and Kubernetes security checklist, which can be used by the security teams. There are some audit questions, but we have auditors who can answer that, so we'll take to them later.
Okay.
But these are the two questions. Are there any scripts, tools available, apps available, which can be used for as a security checklist? And the second one was how frequently they update, how the known vulnerabilities are updated on the containers.
Right. So they happen, one of the things I have to tell you, and because we work so much in the open source space and the communities, right? There is a lot of innovation happening every single day in the open source community and in the what we call the upstream projects. Okay. And just to give you an example, right? Kubernetes is an open source project. Do you know that it gets updated every 90 days? Every 90 days, there's a new version. Okay. And then that is just Kubernetes. Now, Kubernetes has a number of other open source projects that are providing some functionality. For example, I told you that the whole traffic management, between all these containers is done via service mesh, which is a project called Istio in the open source community. Then there is a concept called serverless, where we're talking about Knative, which means an application will scale only as required. When maybe there is an Amazon Prime Day sale or something like that, Republic Day sale or something, and there's a huge traffic, and therefore this application needs to scale for that particular event and then scale back. So that is another project. And then you have another project that takes care of monitoring, called Prometheus. There is another project for something else, Quarkus, I told you about. Now, each of these projects is also having their own life cycle, right? And their own updates, their own contributions, their own changes, right? So you can imagine the complexity in the upstream community. Now, in order to bring sanity to all this, what we do at Red Hat, for example, is, all these, integrated, we provide as a part of our platform, the Kubernetes orchestration platform, OpenShift. I'm just giving you an idea of the complexity. So what happens, we, in order to make sure that our enterprise customers are not, disadvantaged, because, they can't just keep changing and upgrading, every single day, right? So at periodic intervals, we provide the next release if we think there are significant changes that have happened, and then we update to the next version of OpenShift. And OpenShift, while it's a Kubernetes orchestration platform, it comes pre-integrated with all these things, service mesh capability, monitoring capability, your serverless capabilities, and everything else, event-driven management, and everything that we talked about, the management, etc. And then, within, and this I'm just talking about the container platform, right? Now you have the middleware that runs on top of OpenShift, you have the runtimes, and you can imagine each one of them has a life cycle of their own. So I would say in the open source community, several of these are changing very, very rapidly. What we bring to our enterprise customers is a more, what shall I say, curated and a security checked version. And then periodically, we update, based on what vulnerabilities, we have fixed based on the latest, maybe, version that, we are updating across all our things, in which areas we found those vulnerabilities. Like, for example, let us say, I'm now, because we have to guarantee that everything will work together for our customers, right? Across, so what we do is then, let's say JBoss had some errata and some vulnerability that we had to fix. Then that image has to be fixed, and we have to test everything again, right? That it has to work with the rel, it has to work with the thing, we have to do that. So I would say periodically, not very often when you talk about enterprise open source like Red Hat, but in the open source community, every single day there are vulnerabilities that are being found and being fixed. And so that's the reason why it's very important that you have to make sure that those images that you're using are properly certified and have fixed those vulnerabilities before going forward.
So, Ameeta, is there any agency which certifies this? This is my question. I mean, corollary to that. Is there an agency where people can actually? I understand if people are engaged with open source platforms like Red Hat, etc. There is an assurance which is coming from the vendor. But
Correct.
Other than that, is there a common place if people are on open sources, they are able to go back and double check, saying that look, this vulnerability is fixed?
Folks who are active in the open source community will be able to see all those published vulnerabilities. Red Hat, for example, publishes all these vulnerabilities to our customers on a regular basis whenever we have, updated, our images, and, tell them where they can go and find those updated images with that particular fix done. But because of the whole, what shall I say, unpredictability of the whole thing, I'm not able to answer question in terms of how frequently. But in terms of how agencies, are there agencies that do that? Maybe I don't know. Maybe there are. I don't know an answer straight away for that. But there are a lot of standards, there are a lot of policies, and there are a lot of security tools. I'll show you. I'll show you what the tools are in a minute. And
okay.
All
okay.
right.
Thanks, Ameeta. I mean, this complexity is frankly overwhelming, actually.
It is, and that's the reason why I'm trying to keep it as a high level as possible, because there are a lot of details you can get into each of these areas. But anyway, I will share this deck also for people to see later. And then if there are any further questions or any areas, feel free to reach out offline, and I'll be happy to address those.
Great, Ameeta. We have a few questions, but you can continue. Thank you.
Okay. So let me get into then, what are some of the things one needs to look at now? Let us say your applications are now running, your containers are running. What are some of those important things, that one needs to keep about, an eye on, and which are very important, right? And these are basic, very, very basic things. One, any enterprise use of containers requires an operating system. So the operating system is very important, that will help to manage the multi-tenancy of the container runtime, which means you need to have an operating system that can secure containers at the boundaries. If you're able to secure the host kernel, from the container, and if you're able to secure the containers from each other, this becomes extremely important. And I mentioned, right, containers are nothing but Linux processes which have isolation and resource confinement. So you can run sandboxed applications on a shared host kernel, right? So your approach to security containers should be the same as your approach to secure any running process on Linux, right? And there are certain standards that are available. For example, NIST, they have specially published a recommendation about using a container optimized operating system for additional security, right? So when you're using an operating system base, like for example, for Red Hat OpenShift, we use Red Hat Enterprise Linux Core OS. So what happens is, at the OS level itself, you're reducing the attack surface because you're minimizing the host environment and tuning it specifically for containers, right? And then Linux namespaces also provide the fundamentals of container isolation. And a namespace, for example, will make it appear to the processes within the namespace that they have their own instance of the global resources, right? So it provides the necessary abstraction that will give you the impression that you're running on your own operating system from inside a container. So the other thing which I already mentioned, which is a security enhanced Linux, SC Linux, it provides that additional layer of security to keep containers isolated from each other and from the host. And it allows the administrators to be able to enforce certain mandatory access controls for every user, for every application, for process, for files, right? And it acts like a brick wall that will stop you if you manage to somehow break out of that namespace abstraction, either accidentally or on purpose, right? So it mitigates any runtime vulnerabilities. And if you have a well-configured SC Linux, then it can really prevent container processes from escaping their containment, if I can use that word, right? And then there are multiple levels of security, and there's a lot of history behind how Linux is, very secure, and why, and just as a small anecdote, several years ago, the leader at Microsoft at that point of time had called Linux a cancer. And another Microsoft leader said, Linux is good, but it is good for the hobbyist market. It is good for the student market. What a transformation today when you find that the Azure public cloud, for example, is heavily dependent on Linux. So Linux matters. Linux is important. Containers are Linux. If there is one message you take away from this, that is an important message. And you can and should use SC Linux to keep your containers isolated. There are other concepts. I don't want to get into it. You have something called C groups, control groups that will limit and isolate the resource usage. You can even get to the level of the CPU, memory, disk, and the collection of the processes, and ensure that your container won't be stomped on by another container on the same host, right? You can decide which one gets priority, for example, right? So those are some of the things from the OS which matters. And then The other thing which is important when you're working with containers at scale is you need to look at network defense as well. The first line in network defense comes from the network namespaces, right? And each collection of containers, okay, each pod, the collection of containers, we call them as pod, it gets its own entire IP and port range that it can bind to. And therefore, you're able to isolate the pod networks from each other on the node. Now, as you can imagine, this will create a proliferation of IP addresses and ports, and it can make networking more complicated, right? And in addition, containers are being designed to come and go. I told you that when you need a container, it gets spawned up and then it gets destroyed. So you have to invest in some kind of tooling that will handle this complexity for you, right? And for example, OpenShift at Red Hat, we use software-defined networking so that we're able to provide a unified cluster network so that communication between containers across the cluster becomes easier. And we are also able to control what is the traffic that is egress traffic, we talk about it, which is traffic moving out either via a router or a firewall with certain methods. And there are some methods that people will probably be more familiar with, like IP whitelisting for database access, things like that. And then you can have additional security by offering isolation between, I talked about Kubernetes masters, right? The namespaces. And then you can make sure that the packets from one namespace by default will not be visible to another namespace. Pods from different namespaces cannot send packets or receive packets from pods and services of a different namespace. These are some of the ways by which you can isolate the developer, test, and production network. And this is a very interesting use case, which I've come across, which is network scanning, right? So even the network scanning tools, you can containerize them and they can be run as super privileged containers. That's, I thought, a brilliant use case where, then that container can then decide, what should be the access, restrictions or, access that will be provided to a particular container. Then the application access itself, you have APIs, because APIs are very, very important when you talk about microservices, and applications, when they're composed of microservices, each application will have multiple independent API services. So you'll have a lot of service endpoints, right? So you need to have additional tools for that governance. So we recommend using an API management tool, and we have a containerized version of that as well in Red Hat that we call 3-scale API gateway for enhanced. And I'm sure you have others as well. IBM has some, and so do several other vendors. So what happens is you get some standard options when you're using such a tool, for API authentication, security, etc. So instead of using it alone, you can use it in combination to be able to provide the right credentials and control access, right? And you can also set rate limits in terms of how much of API usage you want to allow. You can control the traffic flow from a particular group of developers, and you can set some limits for incoming API calls. That way you can protect your infrastructure and keep the traffic flowing smoothly. And then you can also trigger some kind of alerts for applications that are reaching or exceeding, and then you can define what is the behavior. If I'm reaching that limit, what is it that I need to do? If this is a very critical application, how should my application behave or scale, right? So that one part of it is API authentication. The other part of it is what is the access that you're providing to developers, to administrators, to various service accounts. How can you configure it, so that you can authenticate those people who are trying to access, right? That's the user access part of it. And then you can have, very fine-grained role-based access control, and you can decide, who can have what level of access and things like that. And of course, you will continue to have things like your single sign-on capabilities. It's a key part anyway of today's modern applications, and container platforms are no less. So, if you're going to have containerized services for developers to use, then for an enterprise, you may be able to use single sign-on, and that will, ease up a few things. And there are a whole bunch of SSO kind of, application providers that can help you with that. Then when your applications are running, it's also important that you monitor and audit a cluster. That's a very important part of safeguarding your cluster so that there is no inappropriate usage, right? And I had mentioned there are other open source projects that help you, and you can control the amount of information that is being logged into. You can have audit logs, and you can have audit them periodically. You can have project data available so that project administrators can see how those applications that they are managing are performing. And as a best practice, you have to configure your cluster in a way that all the audit and log events should go to some kind of a security um, information and event management, SIEM system, right? That you call for integrity management, so that you are retaining the data and analyzing the data, right? So you can have the cluster administrators who can deploy the clusters, and then they can aggregate all the logs that they are received, and then they can analyze that at later stages. And there are multiple options today in terms of how you can forward these logs to the SIEM of your choice, right? And then what you don't have to worry about is that there's a huge security ecosystem. I'm sure you're all aware that to meet these existing policies, to integrate with various security tools, you have a huge ecosystem of vendors that are providing you various capabilities, right? Identity and access management. There are external certificate authorities. There are those vaults and key management solutions. There are container content scanners, vulnerability management tools. There are runtime analysis tools, and what I mentioned, security information and event monitoring tools. And if you go with a very comprehensive container security methodology, and what I covered today was, from the build standpoint, how can you control the application security, right? I talked about the content of the container, the registry that the container resides in, the CI/CD pipeline, what are your deployment policies. Then in terms of defending your infrastructure, I talked about the platform. I talked about how you will handle multi-tenancy, how you can plug in storage, how you can isolate your networks, how you can take care of your audit and logging and your API management. And if you want to extend, there is the whole ecosystem of vendors and tools that are providing automation, various services. And to bring it all together, right from your operating system, the host platform, how you're going to manage your infrastructure, where you bring in your whole container orchestration, which can plug into networking, storage, registry, security, etc., and everything that you'll build on top of that, right? Your deployment automation, your service catalogs, where you will pick up your language runtimes, this entire thing, you can bring it all together, and you can create any kind of applications, whether they're for web, they're for mobile. You can have your data and storage, your integrations, your business automation, all as containers, and deploy them across any of these heterogeneous environments. And automation will definitely help to improve security and compliance. And as I mentioned in the beginning, very important for you to make sure that you are baking in automation into your DevOps. You are, your whole infrastructure, your security and compliance is treated as code, which means it has to be verifiable, shareable, repeatable. And then you have continuous monitoring so that you have automated response to alerts. You are remediating them on the fly, and use tools that will help you do that, because it can be sheer madness to try to do all this manually. And to give you an idea about the landscape of security tools, this is the vast world. And I'm sure there is more to it. Okay, I just took a representation. This is the vast world of cyber tech security tools. Use them along with everything that I've told you about, right? For network and infrastructure security, web security, endpoint security, application security, and data security, and so on and so forth, right? This is some image I managed to get that talks about the plethora of tools that are available, right? So what happens when I have several security tools, right? So one of the challenges that many of our customers have been talking about is they are doing security for sure, but they're doing it in pockets. They may be doing for network, they're doing for server, they're doing something endpoint, they're doing something else, but they don't have something that is more holistic, right? So what we're trying to tell them is, and it becomes very confusing when you have several cybersecurity tools in your landscape, right? So one of the interesting things that many of our customers are moving towards is a common language for all their automation. Okay, and Ansible has been the open source project that is leading everything else in the area of automation. And while it is very strong in several areas of automation, we are also advising customers to look at security automation, because if you use a single automation platform, then what happens? It sits on top of your Kubernetes platform, and then Ansible can then have playbooks that can call, and each of the security tool vendors, right? They would have published, their rules, that Ansible is able to access and call. So you can have one common automation platform which can then call those various security tools as required. And while OpenShift will provide some things, Ansible on top of that, you can just make this entire thing a lot more holistic. So DevSecOps has become, while I talked about DevOps, clearly you can see that it is DevSecOps. And this entire thing of automation, many of our customers are at different levels when I look at where is their maturity model, and where they are in the journey. I'm sure there are very less, very, very small percentage where everything is manual and everything is a snowflake, right? That doesn't happen anymore. It used to be some years ago, not anymore. But all this requires a culture change, because no amount of putting a process in place or tools in place will help unless culturally, an organization is able to kind of bring this in as an organization-wide strategy. So we believe the culture change is the most important thing. Then you look at what are the things you can start automating, then start looking at, some of the other things that you can do in terms of, continuous delivery, and then looking at advanced deployment techniques and looking at auto scaling, and then eventually coming to a point where you can really scale with microservices and having an API first approach, looking at, cloud native development and bringing in things like, AI ML. A lot of AI ML workloads are coming in, right? And the sad part of it is, because of AI, a lot of, and automation, a lot of security threats are also, coming in an automated and an AI manner, right? So you have to beat, AI with AI and automation with automation. And therefore, you have to look at your entire pipeline, and the way you would, integrate it into your thing. Once a build is complete, the image is automatically pushed to your private registry, and then you can choose to add signatures to those image as a further security check. And then those signatures can be verified before that image is deployed to production. Things like that. There are a lot of little things you can do, but you can start in baby steps. I really apologize if I overwhelmed you with a lot of information, but it was essential for me to kind of cover the entire plethora of things that you can really bring in from a security standpoint when you have a hybrid cloud strategy and a container approach. And it spans, as I told you, infra, applications, and security ops. But without being overwhelmed with everything that I told you today, the takeaway is that containers are helping organizations become more agile, making their businesses become more responsive. It is helping their IT to also scale to be more responsive to business. A lot of times organizations were spending, almost 70% of their budgets in just keeping the lights on, keeping their infrastructure running. But now they're able to free up more budgets for innovation. There are several companies that are going this way. Kubernetes is relatively new, so you'll not find a lot of expertise out there in the industry, but that's also an opportunity to get skilled in this area of container security, because it becomes so important in this whole journey, to the hybrid cloud. So with that, I end my presentation, and I hope I'm well within time, and happy to answer any questions.
You are, Ameeta. I think I should tell you that the head is spinning for a little bit.
Sorry. I'm seriously sorry.
That's very good. I mean, we didn't know the kind of complexities behind. Just a few questions. I mean, there are quite a lot of questions, and we will come to them one by one, Ameeta. We have some time, so sure. I hope you'll be able to answer those questions. And just my question first: does Red Hat offer any kind of training certifications on this container management or something like that? Is there anything?
Yes, we do. Because OpenShift and containers are a very key strategy for Red Hat. and probably one of the reasons why we were bought for 34 billion, right? Unheard of. An open source company, that has no IP of its own, acquired for 34 billion by IBM. It says a lot for the kind of things that we have done in the open hybrid cloud space and in the container space. So yes, there are instructor-led training programs that are available through our learning services part of the business. And there are some, what shall I say, freely available resources that you can go and check it out on try.openshift.com, I believe, where you can go and try this out for yourself. And there are a lot of YouTube, tutorials and white papers and stuff like that. But yes, there is organized training as well, that's available.
Thank you, Ameeta. Let me take this opportunity to pass the question to one of my executive committee members. So I'm going to pass on this to Mr. Ganeshan Ramani, who is available with us. He's actually a lead auditor, an expert auditor. So I want to ask you this question, Ganeshan, if you could answer this. What are the top 3 attributes that an IS auditor should audit in a containerized app as well as container infra? Yes, we know that logs have to be moved to SIM, etc. But from your auditing experience perspective, Ganeshan, can you just help answer this question?
Yeah, so I think it's a broader question, Vaidi, but I'll make it very short. So from an auditing perspective, I think what goes inside the container, right? The business impact assessment of that particular application, you have to kind of have a close watch and what kind of data goes in and what are the external services from that particular container to the external one. So I think from the cloud perspective also, you can divide that into infrastructure, platform, and a service, right? And it is typically the same thing what you have in your data center, but again it is a different virtual world where it is spinning up, right? So you need to have a clear line of sight on the IT infrastructure side, and specifically on what platform and programming language it runs in, the same software development lifecycle and the security around it, and again your penetration testing or the web application firewalls, what you're going to configure, and if it is going to call some microservices or any other open interfaces, that you have to check. So it is a combination of all the application audits and the IT infrastructure and the platform audits what we put together. So it's a kind of a hybrid control framework where you have to look into all aspects. That's a short answer, Vaidi. Back to you.
Do we need, just as an extension from my side, Ganeshan, do we need any different auditing tools, or can we use the standard IT auditing tools that we are using and the auditing practices that ISACA advises, for auditing this?
No, I think for containers, right now, what I see in the industry is like we can use the traditional audit tools, but again, you never know. Some of the organization can come up with some kind of a smart automation where, like a vulnerability management tool, it can scan a container, take a fingerprint, check all the properties, system properties, and the log properties, so that it can give you a report. So it is possible in the future. Right now, I'm not sure whether we have any tool in the market which can do an automatic scan and fingerprint and provide all the details. But again, in the long run, this would be definitely on the cards, and some organizations might come up with it. But as of now, I think we can still use the manual tools and techniques to go ahead and audit that. Yeah.
Thanks, Ganeshan. This question, Amita, is a straightforward question. Maybe can graphical applications in containers run across different platforms?
They probably can. I haven't, met any, come across any customer that needed that. I mean, at least in my, but I'm sure, there must be. I don't have a ready answer. Sorry.
But I would believe it is
Yeah,
because it is anyway containerized, right? I mean,
correct.
it's not platform dependent actually.
Right.
That's what I would think. Great. Will this session be recorded and shared? Yes, it is already being recorded. It will be uploaded in the YouTube. I could answer that. And I just want to let me just see whether there are any other questions which I can look at here
So
quickly.
why the one in the chat it is there, so I can read that question. So
Oh,
the
I've
question
seen.
is,
Yes. Go ahead, please. Go ahead.
the question is, does Red Hat have a inbuilt BYOK? I think bring your own container or management capability, BYOK management capability, and does it integrate with the HSM based key generation services?
Okay, that last part of it, I don't have the ready answer, but in terms of bring your own container service, what we do is we work very closely with certified cloud service providers. For example, we work very closely with Azure at the engineering level itself, which means you can have managed services from Microsoft for your containers on the Azure cloud. Similarly, we have something called ROSA with Amazon, Red Hat OpenShift on Amazon, AWS. Amazon will provide the managed services along with Red Hat, and you can run your platforms there. We also have several Indian, what we call cloud certified service providers. They will be able to provide those, what shall I say, a container as a platform as a service. In which case, for small and medium businesses, smaller companies, they can just host their, containers on that platform rather than buying, or managing a Kubernetes platform on their own. And you will soon see announcements of managed services for, at least to start with, for application runtimes from Red Hat, as we, work with our customers on the complexity of this whole space.
Yeah.
Ameeta, I think the supplement to the question, this is Ganesan here. There's a question on the BIOK, bring your own key. For example,
Bring
if
your
someone
own
wants,
key. Sorry.
yeah,
Bring your own container is what I heard it as.
no problem. Yeah.
Okay. No, sorry. I don't know that answer, Ganeshan, right away. I can check and let the people
Okay. Thank you.
All the participants, you would see on the screen the feedback form. You could scan the QR code, or you can click the URL and type the code. Please make sure that you do your feedback on the Menti meter, which has been put up on your screen. Two ways to do it. Either you go to the URL and use the code, or you can scan the QR code and do the feedback. Ganesan, anything else?
Maybe I think if you want to take one or two questions, Vaidi, because you have got a lot. Yeah, if Ameeta can answer a few more questions.
Yeah, I can, but some of these very security specific ones, right? I'm not completely familiar with all the policies and, terminology. So you'll have to excuse me if I don't know some of those.
No, that's fine, Ameeta. Yeah. I mean, I'm just looking at questions which are there any further questions on chat? I have not seen chat because most of the question was on how to apply CPE for this. Yes, there are two ways we will answer the CPE question here. If you're, the CPEs, as I mentioned earlier, if you have put in your CPE ISACA ID onto that, the CPE should automatically get recorded. Otherwise, your attendance is recorded. If there is a challenge, because we have been facing off late some challenge with the tools, then we will encourage you. If you don't see it up in due course, please attribute it to some tool problem, which is central, nothing got to do with any individuals here. So please put up your, you can record your CPs individually as well. Ganesan, would you like to add anything onto this?
I think Vaidi, you have covered it. So we are trying our little bit. The last two sessions, we are trying to work with ISACA HQ to kind of get the CPEs updated. And for these sessions, I think hopefully the CPE tool issue is resolved and we will be able to upload the CPE for the current session. So I think our president, Mr. Velmurka Venkatesh, also dropped an email to all the members. So please hold on for the last two sessions. And for this current session, we will try to upload the CPEs from the backend. Yeah, thank you.
I guess pretty much that is where it is. I'm trying to see whether there is, and a lot of people thanking you, Ameeta, for the wonderful session that you've done.
Right. Thank you very much.
Very, informative, and there are asking people talking about what are the use cases, etc., that we will share. For lack of time, we are not able to share.
Sure.
I think it has been a wonderful session, and thank you for sparing your time on a Saturday evening for us. I know it's it's a personal time of yours, but really appreciate you coming in. Really obliged, and thank you. ISACA is thankful to you. And if there are nothing else, I would like to conclude this session. So I thank all the participants, all the ISACA members of Bangalore chapter, and all the executive committee members who have joined this session. And especially once more, our presenter, Ameeta Roy, for making such a wonderful session to all of us. Thank you very much.
Thank you, everyone.
Thank you.
Thanks.
Bye-bye.
Have a great rest of the evening.